Hello, hope you're all doing well. This is an exciting time for all of us, the last test in Mat081, arithmetic. So we're going to look at 15 questions that you should be very competent in, that you understand backwards and forwards, and you will do awesome on this last exam, hopefully how you have done in the other ones. So please contact me if you have any questions. But let's walk through each of the 15 questions and get you ready for that final exam. So we are going to be looking at these 15 questions. One of the things we notice, since we're doing geometry, there'll be times when the formula asks us to use pi. We want to use 3.14 as the approximation for pi, as a rounded number. Okay, so don't use the pi key. If you have a calculator with a pi key, use 3.14. So let's take a look at the first question. Which one of these describes a one-dimensional measure? So remember, one dimension is sort of just like a straight line. Two dimensions would involve a length and a width, so it's going to be a two-dimensional object. Three-dimensional will involve three dimensions, so it's going to have length and width and height. So something like a cube thing. So this is 3 dimensions, this is 2 dimensions, and this is 1 dimension. So first of all, we look at each one. A length of a piece of paper. Well, a piece of paper has 2 dimensions, but the length, maybe length and width, the length is only 1 dimension. Well, that looks like that's going to be our answer. We'll circle it for now, but let's look at the other. The amount of water in a bottle. Now, how do we measure the amount of water in a bottle? Well, even if it's a round bottle, there's a length, a width, a height. So there's the area of the circular area, and then there's a height. There's going to be 3 dimensions involved. Okay, we'll look at questions like this. The bottom surface of a coffee mug, well, a coffee mug, yes, it's circular, it's got 3 dimensions to it, but the bottom one is only going to have 2 dimensions. So something like this would be a 2-dimensional thing. The diagonal of a cell phone screen, so a cell phone screen is here. The diagonal is only one of the dimensions. A cell phone screen is 2-dimensional, but the diagonal itself is 1-dimensional. So there's a little problem here. We have actually 2 correct answers, so hopefully you've chosen both of those as 1-dimensional. The bottom surface of a coffee mug is only a 2-dimensional. The amount of water is a 3-dimensional. So this one actually has 2 correct answers. Now on the exam, you will have questions that only have 1 correct answer. So if you were to see something like this, again, during the test, you should ask me a question. Okay, so let me make a copy of this screen. We move on to the next one. And let's scroll on down to the next question. Okay, so for this question, we're being asked, we've got this diagram. We're supposed to find the area of this diagram, of this utility closet. Okay, so look for the question first. Tim made a diagram of his utility closet shown below. Here it is. The shaded part of the diagram. The side length of each square in the diagram is 1 foot. So we've got 1 foot by 1 foot. So would it make sense that each square is 1 square foot or foot squared? So really all we have to do is count the number of squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 square feet, which is the answer that I'm covering up. I apologize for that. Let me turn this camera off for just a moment. There is the hidden answer right there, 20 square feet, 20 feet squared. So just count the squares and we're good to go. So we'll save this picture and then we'll come back, put the video back on just so that you know who's doing the video, I guess. And let's move on to question 3. Okay, so in question 3, again, the question we're asking is how many kilometers? We're told that Austin ran 2,758 meters. Well, then how many kilometers? And to do this, what we're going to do is we'll take a look at our conversion table, and the part we want to look at is the metric chart. So the base unit is meters, and we're talking distance. We want to go to kilometers, which is over here. So we want to move the decimal from here 1, 2, 3 places. So we're going from meters to kilometers. 1, 2, 3. So let's clear this and go back. What we need to do is the decimal is actually sitting here. We need to move it 3 places. 1, 2, 3. So our answer should be 2.758. 2.758 kilometers. Let's see which one that matches. Here we go with B. Just as simple as that. That's what's nice of working within the metric system. To convert from one unit of measure to the other, you really just need to move the decimal. And that chart that we took a look at back here, this chart is going to be what you're going to want to use every time you're converting within the metric system. Oh, what happened to my... Let me get back to where... Here it is. Okay. Okay, good enough. Let's get another window here, and let's go to number 4. So this one will be a little bit different. The question is, how many kilometers wide is Oregon? Now, on the original printed version, if you've got that, it says Arizona. That was a mistake. It should say Oregon. So Oregon is approximately 400 miles in width. So it's a state. It sort of looks like this. If you've ever seen Oregon, I'm from Oregon, so that's our state of Oregon. And it's approximately 400 miles wide. And we want to convert that to kilometers. So we're going to need a conversion factor. We'll go pick that up. Here's our 400 miles. And remember, the way I showed you is we're going to convert with a fraction. We're going to want to have miles in the bottom. We better spell that out so we don't think of it as meters. So I want to know how many miles converts to how many kilometers. And we'll see what these two are by going to our conversion chart. This window is here. Formulas. And the part of the formulas I'm going to look for It's down here, some metric conversion. That 1 mile, see this one, 1 mile equals 1.61 kilometers. That's the conversion I'm going to want. So 1 miles will go on the bottom, 1.61 kilometers will go on the top. So move this up a little bit here, and then I'll be able to put the 1.61 kilometers here, the 1 mile here. So I was using this one right here. Switch back and forth, come back here. Suppose I can erase this part now, just that part. So when we multiply, the miles are going to cancel each other out. It's 1 times 1 at the bottom, 400 times 1.61. So we just pull up a calculator. Let's use the just the basic one, make it a little easier. So 400 times 1.61, and we get 644. And those are going to be kilometers because that's the unit that's left. There's our answer right there. Excellent. So whichever state you're given, you'll be given how many miles the width is. We're going to use this same type of conversion to figure out how many kilometers. Let's move on to question number 5. I think I'll probably go about to halfway through. So we'll see if we can get to about 7 or 8, and then we'll take a little break, and then I'll do another one. So I will stop there. Okay. So we've got Julia. The question is how many cups, and she needs 54 ounces. So again, what we're going to do is we're going to take our 54 ounces, and abbreviate it OZ over 1. We're going to multiply it by the conversion factor that is going to have ounces in the bottom and cups in the top, if we can find such a deal. Sometimes we got to do multiples, but I think most of these questions are going to be a single conversion. So where do we find the conversion factor? We have to go to our conversion sheet. So we'll flip over to that. We've got some writing in our way, but this is the part up here. Cups is kind of a conversion that deals with volume. So the one we're going to want is ounces converting to cups. So we see the number of ounces, that there are 8 ounces in 1 cup. That's what we want to use right there. So the number of cups is 1 cup. Number of ounces is 8. So that's going to be our conversion factor. Come back to the question. Get rid of this. And what happens here is the ounces will cancel with each other. And so we've got 54 divided by 8, coming straight across, multiplying by 1, and the units that are going to be left is cups. So we take 54 divided by 8. You could roughly estimate that's going to be about almost 7 cups. I think if it was 56, it'd be exactly 7. So you could kind of say, well, it's got to be D, because that's the closest one to 7 cups. However, you could also just put it into the calculator. 54 divided by 8 is going to give you 6.75. So that's how that one works. Let's clear off the screen, move to the next problem, keep things going. Here's number 6. So what are we going to do with this one? Let's go here. The diagram below represents a circular man-made lake. What is the distance around the boundary of the lake? So we want to know the distance around. So how long would it take to go around the lake? That's called circumference. And so what we do know is that we've got a radius here. It's halfway across the circle. So this is the radius. And what we want to find is circumference. If it was rectangular, we would call that perimeter. So circumference and perimeter are kind of the same thing. But with circles, we go to our formula. And where we're going to go is to the second page. We have our shape formulas. And let's see, we've got circle with radius r. These are ones for area. But up at the top here, we've got circumference of a circle is pi times d. D is the diameter, or 2 pi r, where r is the radius. So we're going to use this one, 2 pi r. While we're here, let's go ahead and write that down. 2 pi r. That's going to give us our circumference. Okay. Switch back to our question. And let's plug in the things we know. So we're going to have 2. Remember, pi, we're going to use the number 3.14. And then we're going to multiply by the radius, 24. So 2 times 3.14 times 24. And we can plug that into the calculator. 2 times 3.14 times 24. 150.72. There's our answer, B. Okay. Keep on moving. We'll do one or two more and then we'll take a little break. Or at least I'll take a break. You may keep going. That's going to be up to you. So close that out. And we'll come down to question 7, almost halfway through here. Okay. So now we want to find the perimeter of this shape. And so that's finding how long it takes for the little guy to walk around the building. So he's going to go 15 meters, plus this distance, which we look over here, that's 10 meters, plus this little thing here, another 2 meters. As he comes down this side, this is going to match up with that side, so that's going to be plus 4 meters. And we've got this distance here, which we don't know what it is, but if you notice this total is 15 on the bottom. There's 7 and 2 up here. That is 9. So this must be 15 minus 9, which gives us 6. So that should be 6 meters. So we'll add that in, plus another 6 meters, plus these 4 meters as we go by. Coming this way, we'll pick up another 7 meters. And we get the final 10 meters here, and we're back to where we started. So all we got to do is add all of these together. Okay, so what we might do is take multiples of 10. So we see 4 and 6 is 10. Here's another 10, and here's a 10. There's no other 10, so let's do that. That's 1, 2, 3 10, so there's 30. 15, we just kind of keep counting on. 15 and 30, that's going to give us to 45. So we've taken care of that one. And then what's left? Here's 7 and 4, that's 11. So that's a little easier. 11 plus 45 gets us to 56, and then plus 2 more should be 58 meters. So you can do that with mental arithmetic. You could also pull out the calculator if you'd like, but I wanted to give you that little bit of practice with mental arithmetic. 58 meters is our answer for going around. One other way to do this, if you kind of see the figure, is we've got 15 meters down here, so we're also going to have 15 meters along this top. So we didn't necessarily need to figure out this independent 6. We could have just done 15 plus 15 and 10 plus 10. This gives us a second check. And then we look inside here that we also have these additional internal 4 and 4, so that's going to give us another 8. So we could have done it this way. Here's 30, there's 20 more, so that gets us to 50. Plus another 8, that gets us to 58 meters. Another way to reckon it, maybe a little bit quicker, but whichever way you want to do it, it'll get you the same answer. Awesome. So let's keep rolling along. We'll save that one, and we'll move to question number 8, because I think that'll give us a good place to maybe take a little break. So we've got a triangle. We're asked to find the area of the figure. So for that one, we're going to use a formula for the area of a triangle. Let's take a quick look. I'll show you where it's at on the formula sheet. So if we come down here, area formulas, we see the area formula for a triangle is right here, 1/2 the base times the height. 1/2 the base times the height. So we'll write that down here, 1/2 the base times the height. You could also do base times height and then just divide by 2 is really what's going on here. Okay, so let's switch back to the question. Here we are. So where's the base and where's the height? That's the thing we need to look for. So the base is down here. Do it in darker color. And the height is the vertical height, so that's going to be this 10 yards. So we are going to take the base times the height, 15 yards times 10 yards. Notice that's going to give us yards squared, and then we're going to take and divide all of this by 2. 15 times 10. When you multiply by 10, you can just sort of put a 0 on the end. Remember, powers of 10, so that's going to be 150 divided by 2. And the units are going to be yards squared. So 150 divided by 2 is 75 yards squared. And again, you can pull out the calculator for this one as well, but a little bit of mental arithmetic will help us keep moving along. Okay, so I think that's a good place for me to take a little break. I'm going to get another cup of coffee, and then I'll be back. Let me save this page here, and we'll start up again in the next video with question number 9.